Hi everyone, this video is about derivatives of inverse trigonometric functions, and my name is Professor Oakes. Alright, so let's let u be a differentiable function of x, then the derivative with respect to x of the sine inverse of u is 1 over the square root of 1 minus u squared times du dx. So this is just here because we need to use the chain rule, since this is a function of u here with respect to x. Alright, so the derivative with respect to x of cosine inverse of u is negative 1 over the square root of 1 minus u squared du dx. So notice that these are very similar, but this one here is negative. Alright, so the derivative with respect to x of the tangent inverse of u is 1 over 1 plus u squared du dx. And similar, the derivative with respect to x of the cotangent inverse of u is negative 1 over 1 plus u squared du dx. So again, these two here are the same, except this one is negative. Alright, the derivative with respect to x of the secant inverse of u is 1 over the absolute value of u, square root of u squared minus 1 du dx. And the derivative with respect to x of the cosecant inverse of u is negative 1 over the absolute value of u, square root of u squared minus 1 du dx. And again, these two are very similar, except this one is negative. So now, let's differentiate each of these functions. So f of x is 2 sine inverse of x minus 1. So here is the u. It's x minus 1, and du dx is 1. So f prime of x will be 1 over the square root of 1 minus u squared du dx. So it's 1 over. All right, now, by the way, we have this 2 here, but we could deal with that later, but I'm just going to actually write the 2 here so that we don't forget it at the end. All right, so if we do that, 2 over the square root of 1 minus x minus 1 squared times du dx, which is 1. All right, so this is just 2 over the square root of 1 minus x minus 1 squared. What a time to be alive. Now let's try another one. We have the y equals 8 sine inverse of x over 4 minus x times the square root of 16 minus x squared over 2. So we have a lot going on here. So let's just first start with the derivative of 8 times sine inverse of x over 4. So the u is x over 4, or 1 over 4x, all right, however you want to write that. So du dx is 1/4. So y prime will be 8 times 1 over the square root of 1 minus u squared. So 1 minus x over 4 squared times du dx, which is 1/4. And then we need to rewrite this part here as, well, one way to write this is negative 1/2 x, then 16 minus x squared to the 1/2 power. All right, then we can use the product rule, and I can let u be the negative 1/2 x, and the v be 16 minus x squared to the 1/2 power. So u prime is negative 1/2. V prime is 1/2, 16 minus x squared to the negative 1/2, and then use the chain rule. The derivative of 16 minus x squared is negative 2x. All right, so now this is actually, these 2's divide out. So 1 times negative x is negative x all over. I'll bring this back to the denominator, so the 16 minus x squared to the 1/2 power, or just the square root of 16 minus x squared in the denominator. All right, so now let's write this out here. So the product rule says it's going to be VU prime, so minus 1/2, and this is also square root of 16 minus x squared. Then plus uv prime, so minus 1/2 x times the negative x over the square root of 16 minus x squared. And now, then, what can you do? You can actually just, well, you could leave it like this if you like, but there's a lot of simplifying that you could do. So actually, why don't we write this over 1 so we can get ready to find the common denominator. So 8 times a fourth is actually 2. So we have 2 over the square root, and I'll make that 1 minus x squared over 16 minus, all right, so we have the square root of 16 minus x squared over 2 minus, all right, and a minus times a negative makes a plus, so x times x squared over 2 square root of 16 minus x squared in the denominator. Now, let's find common denominator. So this is actually 1 over 1, so we'll multiply by 16 over 16 here. And the square root of 16 minus x squared, and the square root of 16 minus x squared here. So we have 2 over the square root of 16 minus x squared over 16 minus, if I multiply these two together, 16 minus x squared over 2 square root of 16 minus x squared plus x squared over 2 square root of 16 minus x squared. And then what do I do here? I have the square root of 16 is 4, so I have 2 over the square root of 16 minus x squared over 4, and then I'll actually distribute this negative here, so don't forget to distribute that negative here. So that well, these already have the same denominator, so just be careful about all this. So whatever I get here will all be over the 2 square root of 16 minus x squared, all right? So negative 16 plus x squared plus x squared, all right? So now I'll multiply this by the reciprocal, so 2 over the square root of 16 minus x squared times 4, and then that will be plus negative 16 plus 2x squared over 2 square root of 16 minus x squared. And now, what do I do here? All right, now there's lots of ways you can do this, but if I multiply this by another 2 over 2 here, I have a common denominator again. So I have 2 times 4 times 2 is actually 16. All right, so 16, and then minus 16 plus 2x squared over 2 square root of 16 minus x squared. The 16 zero out, so I have 2x squared over 2 square root of 16 minus x squared. The 2's divide out, and I'm left with x squared over the square root of 16 minus x squared. So what a time to be alive. All right, so I really enjoy algebra, just like I hope that you do, so I hope that you would take the time to simplify this. If you're a real extremist out there, you might actually even rationalize the denominator here, but I'm not that extreme. I like algebra, but not that much. And so for me, even though I like algebra, I probably would have just left it like this, just so that I know for sure I don't make any unnecessary algebra mistakes, because even after doing hours of algebra, everyone could even get a different answer that is equivalent, but they all look different depending on where in this process someone stopped and whether somebody even decided to rationalize the denominator or not. And so I would just stop up here just to be safe. All right, so as long as you have a correct derivative, it is fine with me. All right, so keep that in mind, everyone. So let's try another example. In this example, we have g of x is cosine inverse of x over x plus 1. So we can use the quotient rule to find the derivative. So let's let u be the numerator, cosine inverse of x, and v be the denominator, x plus 1. So u prime then is negative 1 over the square root of 1 minus x squared. And v prime will be equal to 1. So g prime of x using the quotient rule is vu prime minus uv prime all over v squared. So this will be x plus 1 times the negative 1 over the square root of 1 minus x squared minus cosine inverse of x times 1 all over x plus 1 squared. And then let's do a little bit of algebra here. So we have negative x plus 1 all over the square root of 1 minus x squared minus cosine inverse of x all over x plus 1 squared. So let's find a common denominator here in the numerator. So we'll multiply by the square root of 1 minus x squared over square root of 1 minus x squared, square root of 1 minus x squared over square root of 1 minus x squared. So now, let's see, what do we have? Well, in the first term here, the square root of 1 minus x squared divide out. And then, let's see, what do we have next? Well, that looks to be all we can really do here, right? So we have, negative x plus 1 minus cosine inverse of x times the square root of 1 minus x squared all over the square root of 1 minus x squared. And this is actually x plus 1 squared over 1, so I'll multiply by the reciprocal. So times x plus 1 squared, or 1 over x plus 1 squared. So this is really all I can do to simplify this. All right, so I have something that looks like this. All right, so now you can try these two on your own. I hope that you have a great time doing that. And let's do another example here. The derivative of f of x equals secant inverse of the square root of x squared plus 9. So let's let u be the x squared plus 9 to the 1/2 power then. So du dx is 1/2 times x squared plus 9 to the negative 1/2 power times the derivative of x squared plus 9, which is 2x. The 2's divide out, so this will be x over 1 times x over, and I'll make this come back to the denominator, so x squared plus 9 to the 1/2 power, or that's x over the square root of x squared plus 9. So that means f prime of x is, all right, so this will be 1 over the absolute value of u times the square root of u squared minus 1 times du dx. So 1 over the absolute value of the square root of x squared plus 9 times the square root of the square root of x squared plus 9 squared minus 1 times x over the square root of x squared plus 9. Now, this square root of x squared plus 9 squared is just x squared plus 9 minus 1, which will give us x squared plus 8 under the square root. And we know that the square root of x squared plus 9 times the square root of x squared plus 9 is x squared plus 9. And actually here, the absolute value is redundant or not necessary because what is under the square root must be positive regardless. So we have 1 times x is x. Then we have the square root of x squared plus 9 times square root of x squared plus 9 is x squared plus 9. And then the square root of the x squared plus 8. All right, what a time to be alive. Again, I don't really always expect you to do all of this algebra, but a lot of times it is enjoyable and very satisfying, at least for me. So now, here is another great example here. Let's use implicit differentiation to find the derivative of y with respect to x. So dx of x squared plus x arctangent of y equals y minus 1. So the derivative with respect to x of x squared is 2x, and then dx of x arctangent of y, we'll need to use the product rule. So the u will be x, v will be arctangent of y, u prime will be 1, v prime will be 1 over 1 plus y squared dy dx. All right, so now we know using the product rule, this will be u prime v plus u v prime. So that gives us arctangent of y times 1. So arctangent of y times 1 plus the x times 1 over 1 plus y squared dy dx is equal to the derivative of y, which is dy dx, minus 0, which is the derivative of 1. And now what I need to do is actually subtract this term to this other side so that all of the dy dx's are on the same side of the equation. So what I have here is 2x plus arctangent of y equals dy dx minus x over 1 plus y squared dy dx. I'll factor out dy dx, so I have 2x plus arctangent of y equals 1 minus x over 1 plus y squared dy dx. And then I'll divide by 1 minus x over 1 plus y squared to get 2x plus arctangent of y all over 1 minus x over 1 plus y squared is dy dx. And this time, I think I'll leave it like this without all the extra algebra. But I think that if you wanted to do the extra algebra, you could, and that it would be a great thing to do for just something fun to do, all right? So now let's do another example. Use implicit differentiation to derive the rule for differentiation of this should be cosecant inverse of u. So let's let y be cosecant inverse of u. Then the derivative with respect to x of y equals cosecant inverse of u. All right, so now I know that y is equal to the cosecant inverse of u is equivalent to u is cosecant of y. All right, so then the derivative with respect to x of u is du dx, and the derivative with respect to x of cosecant of y is negative cosecant of y, cotangent of y, dy dx. And now I can solve for dy dx. So that is du dx all over negative cosecant of y, cotangent of y, equals dy dx. And then remember that u was cosecant of y, so that means that du dx over negative cosecant of y, cotangent of y, becomes du dx over negative. And by the way, how would you figure out what the cotangent of y is? Well, you could use the identity of 1 plus cotangent squared y is cosecant squared y. So we have 1 plus cotangent squared y is equal to u squared, since cosecant of y was u. And then I'll subtract 1 to get cotangent squared y is u squared minus 1. And then I'll take the square root. So cotangent of y is the square root of u squared minus 1. So now this becomes, all right, negative absolute value of u, square root of u squared minus 1 equals dy dx. And, well, that was the formula for the derivative with respect to x of cosecant inverse of u, or the rule for finding this derivative. So we saw it though as negative 1 over absolute value of u, square root of u squared minus 1 du dx equals dy dx. Right? So what a time to be alive. I hope that you enjoyed this video on the derivatives of inverse trigonometric functions, and that you are already looking forward to the next video. Thank you for watching, and have a great day, everyone.